Alright, in this video we're going to just finish up the problem that we started in the last video. And so we had a block sliding down a ramp, so there was a force of gravity kind of making it slide down the ramp. In addition to that, I was pushing it down, and then we had the force of friction, which is pretty slight, that was slowing it down a little bit. And so we found out that the net work was 938.6 joules, so that must be the change in the kinetic energy. So we had 938.6 joules equals the change in kinetic energy. And let's see, the block started off at 2 meters per second. So if I wanted to get the initial kinetic energy, what was the mass again? 20 kilograms, alright. So we'd have 1/2 times 20 kilograms times 2 meters per second squared, and that would give us 40 joules. That's our initial kinetic energy. And we know that the change in kinetic energy was 938.6 joules. So the way I could write that, right, would be that that's equal to the final kinetic energy minus the initial kinetic energy. And I want to figure out what the final kinetic energy is. I don't really know. I don't know how fast it's going. So let's just set this up as 138.6 joules equals the final kinetic energy, which we don't know, minus 40 joules, which is the initial, which we do know. Right, so we just add 40 to both sides, and we get 978.6 joules is equal to the final kinetic energy. And if I want to know what the velocity of the block is, right, in 2 videos ago, in the first practice problem we did, we found out that we could find velocity using the kinetic energy formula, and that would be equal to 2 times the kinetic energy divided by the mass, take the square root of that quantity, and you would get the velocity. So let's do that with our problem. So we're going to take the square root of 2 times 978.6 joules divided by our mass, 20 kilograms, and we'll get 9.9 meters per second. And although that took a pretty long time to get, compared to the amount of time it would take us to figure out how to do that just using Newton's laws, it would have been much harder to do it that way. And this is part of the reason why thinking about energy and energy transfer and work is a very powerful tool to analyze kind of how things will move and how they'll react to different things. So just to recap the steps that we took. First, we found the net work, and we did that by adding up all the different types of work. So we had the work that I did by pushing the block. We had the work done by friction going against the motion of the block. And then we had the work done by gravity, which was pulling the block down and having it slide down the ramp. We found the net work. We said, okay, well, the net work's got to equal the change in kinetic energy. So we set them equal to each other. Then we found the initial kinetic energy. Once we solved for that, we could use the change in kinetic energy and the initial kinetic energy to find the final kinetic energy. And once we had the final kinetic energy, we could use it to solve for the velocity by going kind of backwards. And then we found the final velocity as 9.9 meters per second. So over that 5 meters, it increased in velocity by 7.9 meters per second.